Hey everybody, my name is Tom Tullis. This is the Tomb of 3D Printed Horrors, and this is our introduction to 3D printing video. So if you have a lot of experience with 3D printing terrain and minis, this is not the video for you. This is for people who are just looking to enter the hobby and don't know where to start. So we're going to have this new category here on the channel. It's called 3D Printing 101, and in it I will cover the very basics of how to get started in this hobby, from good filament practices, how to handle it, how to store it, how to clean your build plates, just very, very basic level stuff, but it's stuff we all need to know to get started in this hobby. So this video is going to be a very brief introduction to the hobby. I will first answer the more commonly asked questions I get from people who are looking to start getting their first printer and start printing terrain and minis at home. Then I will give a brief overview of how a FDM printer works, what the print process is from when you download the model to actually putting it on the printer and getting it to print out. And then we'll go over some basic maintenance and upkeep that's necessary on these printers so you can make a decision whether this is right for you or not. Additional videos will cover best practices for how to handle filament, build plates, things like that. Just everything we all need to know and learn to get started in this hobby. Beyond that, if you want more in-depth information on types of printers, how to set up the more common printers, how to maintain them, I have a lot of other videos on this channel that will help you out, so check those out too. So with that, let's get started with the more commonly asked questions I get. All right, the first questions I usually get asked about people wanting to get into 3D printing are, what are the pros and cons of it? Is it expensive? Is it safe? So let's tackle those right off the bat here. The pros and cons of 3D printing. We'll start with the cons, and that is the time investment. It's not like going to the store, buying a box of terrain, coming home and dumping it on your table and it's ready to play. You do have to take the time to print it out. So it's not going to be as fast as just buying pre-made terrain. So that's your con. The pros far outweigh this. To begin with, where with store-bought terrain, it's a pre-packaged amount of terrain. And let's say it has 10 walls, 4 corners, and 2 doors. And you get your dungeon layout done and you need a third door or another corner or just one more 2-inch wall. Well, with pre-made terrain, you've got to go buy a whole nother box set of terrain, even though you only may need 2 or 3 pieces out of it to complete your layout. Whereas with 3D printing, you print exactly the amount of items you want and precisely what items you need for your layout, and only that. So if you have a layout that you need one more door for and a couple extra wall sections, you just go and you print just those pieces out. So you're never paying for something you're not going to use. So that's probably one of the biggest pros of 3D printing. You can tailor it to your exact needs. You don't have to just spend your money on a bunch of stuff you don't want or don't need to get the 1 or 2 items that you do. Now, in addition to this, you can maintain a massive collection of terrain and miniatures on your hard drive. And then when you need that one exact piece, you just go and you print it out. So it lets you keep an archive or a library of just a huge amount of options on your computer that you can call up at any time and print it out. So it's very versatile. It is not very expensive to get into this hobby. A great starter FDM printer can be found for in the range of $200 to $300, depending on the brand. And I will go more into the types of printers and my recommended printers later in this video. But to get started, you're looking at $200 to $300. So that's not terrible for the amount of savings you will see in not having to buy pre-made terrain. Now, just to give you an idea of what an individual model will cost, for a standard dungeon wall and tile, it's going to be around 40 cents in plastic. For a miniature, you're probably looking at 8 cents. Now, this is a standard humanoid miniature, not a dragon or something, but just a standard player character human, probably about 8 cents. So there's another pro for this. It is incredibly cheap as far as materials to print this stuff out. As far as buying the files, it just depends where you buy them from. Our stuff at Fat Dragon, we try to price it very, very competitively. You just have to shop around. You can you drive through RPG and stuff. You can find sales periodically. But as far as materials cost, it's very, very inexpensive. Now, safety. Safety comes down to the type of printer you select. And again, I'm going to go into the types coming up here shortly, but they fall into two categories, either a liquid resin printer or a filament printer. Now, liquid resin. Liquid resin is toxic. You cannot get it on your bare skin under any circumstances. It is very bad for you. You do not want that seeping into your skin. Liquid resin also gives off high amounts of VOCs. VOCs are volatile organic compounds. These can accumulate in your body. VOCs are known to cause health issues, both respiratory. They can attack your immune system and you'll become sensitized to them. VOCs can also cause things like kidney and liver issues. So if you are going to use resin, you must take proper safety precautions. That means you have to have, to really use this safely, you need an active air exchange system in the room you're using it in. That means you're pumping in clean air and expelling the bad air. You should be using a respirator with an organics filter on it anytime you are around the printer. Nitrile gloves, goggles so you don't splash it and get it in your eyes, long sleeves so when splashes do occur you don't get it on your skin. I really don't recommend resin printers for people just getting into the hobby. I don't use them because of the safety issues, but you know, if you want to, there are other videos on YouTube that'll tell you how to get in and get one set up. Now, the other type of printer is an FDM printer. This is a fused deposition modeling printer. And what this does is it takes a roll of filament, plastic filament, and it comes on a spool, and it feeds into the printer. It is melted and extruded out. Now, FDM printers. FDM printers can be very safe, or they can have issues like resin printers. It all comes down to the type of plastic you're feeding into it. Now, for gaming miniatures and terrain, you want to use a plastic called PLA, and that stands for polylactic acid. This is a bioplastic that is made from corn and sometimes sugarcane. There are no toxic chemicals in this. It's very, very safe to use. And it's the best thing you can use for gaming terrain and miniatures with tiny details. So as long as you stick with PLA, your printer is going to be very safe to operate and be around, have your family around, pets, whatever. There are plastics that have toxic chemicals in them like ABS that can be fed into an FDM printers. Just don't use those. Stick with PLA and you're going to be fine. Okay, next, what are the types of 3D printers? Well, I just touched on those. The two main types of printers on the market are FDM, fused deposition modeling, that uses spools of filament line that are then fed into the printer, melted, and deposited on a build plate. The other type are liquid resin printers, and as I outlined earlier, I really don't recommend them for someone just getting into the hobby. If you want to, that's great, but it's not something I use, and so it's not something I'm going to cover in any of the videos on my channel here. To give you an idea what an FDM printer looks like, this is a standard design here. This is an Ender 3. This is also known as a Cartesian printer. They're also called bed slingers because the bed that the model is built on moves back and forth. So that's just usually, if you hear that term bed slinger, this is what you're talking about here. You have a print head assembly. That print head assembly will move back and forth and up and down. The build plate will move front to back, and then your spool will either mount on the top of the printer or off to the side and is then fed in by an extruder motor. When you're talking about a Cartesian printer, and then there's multiple types of FDM printers. There's Core XY, there's Deltas, but the most common type are the Cartesian or bed slinger, which is what you're seeing here. When I say Cartesian, what do I mean? Cartesian just refers to the Cartesian mathematical coordinate system for designating points in a three-dimensional volume. We all learned this in high school geometry class. You had an x-coordinate, a y-coordinate, and a z-coordinate, and when you put all three together, you were able to determine the point in a three-dimensional volume where an object was. So a Cartesian 3D printer operates on those the principles of X, Y, and Z for depositing plastic. In the case of the Creality Ender 3 here, the X-axis is the print head moving left to right. The Y-axis is the bed moving front to back. And then finally, your Z-axis is your print head moving up and down. So that gives you motion in three directions, up and down, left and right, front to back. And with those three directions of movement, you can deposit plastic anywhere in the build volume of the 3D printer. So that's the only reason it's called a Cartesian printer, is it uses the Cartesian coordinate system. So these type printers, you use a spool of plastic. I prefer PLA, polylactic acid, because it's a bioplastic, it's very safe, and you don't have to worry about any toxic fumes. These are just some sample miniatures that you can print on an FDM printer. With the ones I recommend at the end of this video, not all FDM printers are capable of printing this well, but the ones I will recommend at the end of the video are. Now, you can print anything from the 28mm skeletons, this barbarian here, all the way up to like this war turtle and such. These were all done on FDM. In the case of things like the war turtle, that is a multi-piece print. And that way it can print supportless. One of the drawbacks to FDM is if you have a lot of overhangs, if the model is not designed for FDM printing, it can create some hassles for you. I know my company, Fat Dragon Games, everything we design is designed to print supportless for FDM, and there's other companies that do too, and usually they will designate their models as such. This is the badge that we use on all of our models. It just means that the print is going to print off on your FDM much, much easier. There will be less hassle and less chances for print failure, and you won't have to hassle with things like supports and break them away and then sand the model down and stuff. It'll print exactly as it is designed to on the build plate, and you won't have to do any finishing with it. Another question I get asked very, very often is, what exactly can I print? Can I print something that looks like and is functional like pre-made terrain? And the answer is yes, you can. When it comes to miniatures, you can print anything from standard 28mm size characters like these skeletons all the way up to dragons. Now this dragon is probably about 14 inches long. It does print in multiple parts. What this does is allow it to be printed on a smaller build plate, so you don't need an enormous printer, and it allows it to print on an FDM printer without any supports, which means the parts all print as they are. They don't require a lot of trimming and sanding or anything. You just pull them off the build plate and glue them together. So you can print very, very detailed things on an FDM printer as long as the model is designed for it. Probably the most common feature people don't think they can do with 3D printing is LED lighting, and that's simply not the case. We have a lot of models, a lot of terrain offerings in our catalog that are designed for LED lights. And everything we design for LEDs is done in a way that does not require you to know how to solder or do any type of custom wiring. Everything we do, like these LED mushrooms, or the fire braziers here on this Temple of Orcus, or this dungeon layout, we have a fire brazier in front of the statue. We also have an opening pit trap with hot coals in it that are lit by LEDs. But in all of these cases, the LEDs are simply pressure fit. The leads on them, the little wire leads, are just wrapped around a printed battery tray. And then that battery tray, when you insert the battery, it's a pressure fit. Again, there's no soldering or anything. It will activate the LED, and then you simply insert it into the terrain piece, like this LED scrying pool here. So you don't have to know how to solder or wire anything to install LEDs in a lot of the terrain offerings that are out there, and no soldering is required for anything from Fat Dragon Games. So that gives you a little bit of an idea of how detailed things can get. You can have opening doors, LEDs, functional trap. So you can do most things, if not everything, that you can do with pre-made, factory-made, store-bought terrain. Now, the question everybody has when they're getting into this hobby is, how exactly does a 3D printer work? Now, I'll have a separate video on my channel in this category, 3D Printing 101, that goes into a lot more depth on how a printer operates and what all of the parts are. But for this introductory video, we'll just hit the high points and discuss the common parts of an FDM printer that make it print. We've already gone over the Cartesian coordinate system, which is your print head moving on the x-axis left to right, z-axis up to down, and the print bed moving on the y-axis front to back. Now, that's great for moving in 3 dimensions, but you've got to have something deposited in order to build a model. You have to have plastic to form the shell of the model you want to print. So the print head assembly for all FDM type printers is essentially the same. You're going to have the same basic components. Sometimes they're arranged a little bit differently, but they all operate on the same principle, which is you're going to take a solid line of plastic filament, melt it, and deposit it out of a nozzle onto the build surface. It does this primarily with 2 key components. Those are the extruder, which is a motor with a feed gear. This is what grabs onto the plastic line of filament and feeds it down into the next section, which is your hot end. The hot end is responsible for heating the filament to a liquid state and then squirting it out the nozzle at the bottom onto the build surface. So the hot end melts it, the extruder feeds it. So what's happening is the extruder will grip onto the line of plastic filament. It's still solid at this point, and it will feed it down into the hot end. Now, at the bottom part of the hot end, that is where the heating actually occurs, in your melt area. The plastic will get very soft and eventually turn to a liquid. That liquid is then extruded out the bottom of the nozzle onto the build plate as a line of extruded filament. And that's essentially the process here, and we'll look at this a little more closely in a minute. But when you're looking to buy a printer, you're going to see 2 terms for these FDM printers. One are direct drive extruders, and the other is Bowden drive extruders. And the only difference is where the extruder is located in relation to the hot end. With a direct drive extruder, the extruder is immediately above the hot end and feeds the plastic directly into it. Whereas with a Bowden extruder, the extruder is off to the side on another section of the printer, and it feeds filament through a plastic tube to the hot end. And there's advantages and disadvantages to both. I will go through this in my recommended printers, but most newer printers, especially beginner printers, are going to be direct drive extruders because they are easier to maintain, they're easier to set up, and they tend to have fewer issues while printing. Bowden extruders are very, very light because they don't have to travel and move with the added weight of the extruder motor and such, which means they are usually capable of a lot finer detail work. But there are exceptions to this. And again, I will go through those at the end of this video when I'm talking about recommended printers. But just for you right now listening to this and just getting into this, direct drive means the extruder is connected to the hot end. Bowden extruder just means the extruder is somewhere in a different location on the printer and feeds the filament to the hot end via a tube. And here's a photo of a Bowden fed system where the extruder is over on the left hand side there. It has that blue cap on it. It then feeds the filament through that white tube to the hot end. In this case, the extruder is mounted right on top of the hot end. The filament goes directly into it and then is fed directly into the hot end at the bottom. So those are the two types of FDM printers that you'll be faced with choosing and stuff. And again, we'll go through recommended printers in a moment at the end of this video. Okay, so once you have your printer set up, the next thing people want to know is, how do I actually print a model? Well, the first thing you're going to do is go and download it, like from DriveThruRPG, where we sell our models at. Once you have the model, that model is not ready yet for printing. It is just going to be a shell file, usually in STL file format, and that is just a description of the volume of the model, the outer skin, if you want to think of it that way. It does not contain any of the information that the printer needs to actually print it. And to do that, you need to run it through a piece of software called a slicer. Now, a slicer does exactly what the name implies. It's going to slice that model up into individual layers so that the printer knows how to print it, how to move the nozzle, what temperature to set the nozzle out, how far to move it up between each layer. All of that information will be encoded in this slice file. So there's a lot of different slicers on the market. Different printers have different recommended ones. For most Creality printers, Cura is what a lot of people use. There's also Prusa Slicer if you have a Prusa printer. Bamboo Lab uses their own proprietary software. But they all kind of operate basically the same. They're just prepping that file for printing. So in this case, we're going to go into Cura, and you can either select a pre-made profile that Cura provides, or in my case, I'm using a custom one, and I make all of my custom profiles available for free on DriveThruRPG. It's linked in the video description. You will then open your file that you downloaded into Cura. And Cura will show you a preview like you're seeing here of each file, so you can make sure you get the right one selected. Once you find the one you want, you click Open. It will appear on the virtual desktop. Then you click Slice. You can also go in and manually adjust any settings if you want, but if you're just beginning, just use the preset ones. Once it's sliced, you're going to save it to your removable drive. So, next step, you're going to take your SD card. Now, some printers, you can do this wirelessly. Others, you're going to load it on an SD card and insert it into the printer. Once you've done that, you're going to go in. You're going to turn the printer on. Wait for it to come on. The LCD will take a minute to boot up. Once it has booted up, you're going to go in and select in the print menu and select the file that you just sliced in Cura and tell it to print. Now, it's going to take a few minutes. I'm going to speed this up here, but it'll take a few minutes to preheat. Once it does, it'll do an auto homing, and it's just finding its start point so it knows where to print the model. And again, this is speeded up about 500%, so it's going to go really fast, but it's going to start drawing your model out layer by layer on the print bed. At this point, you're done. Go off, watch TV, read a book, eat some dinner, whatever. When you come back, your print will be done. And again, this is just really, really sped up. Typical, if you're running a miniature, it can run an hour, hour and a half. Terrain tile like this will take several hours. But it's going to build it up layer by layer. And when it's done, the tray will come forward. And when it's done, the machine will cool down. The build bed will go back to its home position. And you have a finished model. Finally, most people want to know how much maintenance there is for one of these printers. Well, maintenance kind of falls into two categories. There's routine preventative maintenance. This is very, very easy. The most critical thing is keep your printer clean. If you start getting a buildup of dust and stuff on it, take a damp paper towel, wipe it down, keep it clean. You have moving parts on this and they need to move freely. If you get a bunch of dirt and lint and everything on it, it's going to hinder how your printer works and how good your prints turn out. So just maybe every other week, wipe it down, get in the rails, keep it clean. Beyond that, you're periodically going to want to check your rubber belts on it for proper tension. If they get too loose, your print quality will decline. Most printers, this is accomplished just by an adjustment wheel on each axis, and you just turn it until the belt is tight and just make sure it hasn't loosened any. So it takes you about 5 seconds per belt and you're done. Do this maybe once a month. Beyond that, any metal surfaces that has metal to metal contact, like your Z-axis screw or any guide rails, you're going to want to put a drop or two of oil on these once a month, just to keep things, reduce friction, keep them in good working order, and keep them from wearing out. Again, very, very simple stuff. Usually every 6 months, I'll go through and with a screwdriver and just check the screws on the printer. These printers move a lot. There is a lot of vibration, and once in a while, a screw can come loose. Every 6 months or so, go through with a screwdriver. Just make sure everything's nice and tight. Again, this isn't complicated stuff. Now, beyond preventative maintenance, once in a while, there are things that wear out on a printer. The most common thing to wear out is your nozzle. It's made of brass. It will wear out. I have videos on this channel for how to change them out. There's not a lot to it. It'll take you, in the case of an Ender 3 V3 SE, it'll take you 5 minutes. With a Bamboo Lab printer, it's probably going to take you about 30 seconds. But it's not a hard thing. It's just unscrewing it, or in the case of Bamboo Labs, you just unsnap it and pull it out. But ultimately, it's a very, very simple thing to do. If you have a Bowden tube printer, Bowden feed extruder, once in a while you have to change the tube out. Again, this isn't a major process, but you're going to want to do it every 6 months, and it'll probably take you 15 to 20 minutes. Okay, so that is an overview of the 3D printing hobby. I've decided to separate my recommended starter printers into a separate video. It is linked above right now. It is also linked in the video description. This way I can change that, keep this video intact, but update that next video as new printers come on the market. And that way, if at any time you want to get a new printer, you can check back here and just check that separate video on current recommended printers for whatever the new things on the market are, so that it's always up to date. So in the meantime, before you click on that link, if you would, please click that like and subscribe button. That definitely helps me out with the channel here. If you have any other questions about 3D printing, my channel, Tomb of 3D Printed Horrors, has pretty much everything you could want to know about it. I go through how to set up the more common types of printers on the market, how to troubleshoot them, and if something does break on your printer, how to fix the most common items on it that do go out. So if you do need more information, please check that out, and thank you for watching.